Today we're going to take a look at a few of the ways in AI that we can work with moving mapped setups. Okay, so let's think about the most simple one first of all. Let's imagine we've got a screen that's hanging on stage. It's hanging from a kinesis motor system, and we just simply want the screen to move up and down when the kinesis system moves up and down. Okay, so this is the easiest one that we can do. Let's add a projector first of all. I'm going to give that a correct aspect ratio of 16:9. Let's give it a lens ratio of 1.8 because that's a good average. And then let's just pull it out on the Z just to give ourselves a good bit of coverage. Maybe a little bit more. There we go, that's great. Okay, so what we'll also do, let's go to our output page. And let's just make sure the projector is turned on. Brilliant. And then what we're going to do, I'm actually going to give myself a little window because we're going to work from the stage patch a little bit here, and it will just help us to see what's going on if I have that window there as well. Okay, that's great. So within the screen fixture itself, there are commonly more ports and more parameters available on the unit than you will start with by default. So what we need to do first of all, we need to expose some of these hidden ports. Now I'm going to right click on the module itself, and I'm going to choose Load Alternate Skin, and then in the menu that pops up I'm going to choose Dynamic Adjustment. So the benefits of this particular skin are that it gives us direct input to control things like the position of the screen, the angle of the screen, and the sizing of the screen. So we mentioned that we want to go up and down with this one, so we should hopefully see it moving up and down within our projector area. Now I mentioned the idea of kinesis, so I'll show you where to find that module. So we right click in an empty area, we choose Insert Module, and then we go to Motion Control, and then Kinesis Listener, like so. Now if I had a kinesis unit attached to AI at the moment, my network adapter would show up here, and I could select the one that's connected to the kinesis unit. My construct ID is a way of me identifying specifically which kinesis motor I'm listening to, which is very useful if you've got a system which involves more than one. And then what we would do is we would connect the direction of choice to the adjustment of choice. So by that my Y direction would connect to my Y position adjustment port. Once connected, we could then initialize the unit, and then when you move the motor system we should see this screen moving up and down. Now obviously I don't have a kinesis system connected at the moment, so I'm going to just add an on-screen controller constant. Let's connect that into the port, so you can see that when I move that, it should control the position in real time of that screen. Now just to confirm what we're seeing on the output page, I'm going to put in a controller LFO, and so this will just give us a constantly adjusting control value. Think of it like a shape on a Titan console. There you go, so you can actually see what that's doing now. It's making it go up and down here. Then if we go to the output page itself, we can actually see that it's falling within the area of that projector beam. Okay, so that's the first one. That's really nice and easy. Obviously I've got it on this oscillator, so it's bouncing up and down, but if you had it controlled from your motor system, it would only move when you activate the motor system. So next, let's think about rotating objects. So some of you may have seen in the past, we did a demonstration of a Lego constructed tower that we had on a rotating turntable, which was mapped in real time. So let's show you how we go about that. So I'm going to go back to my stage construction page. Now I've got a special model which I'm going to place onto my screen fixture here. So if I go into my browser over here, and inside my folder here, I've got a models folder. There we go. Spin cube. Let's throw him onto there. I'm just going to adjust my resolution because I know that's not correct. There we go. Now if I press show canvas, we can see, there we go. If I spin the world around, we see it's nicely UV mapped, so the image goes around the edge of it. So if we go back to, if we have a look at our output first, in fact, we can see that we're looking at it flat on with this one, so it looks like it's a square, although it's a 3D object. Then we'll go back to our stage construction, our stage patch. So this time, if I connect that LFO into the Y angle adjust, we'll see a little bit of movement. If I bring that window up a bit, you'll maybe be able to see the movement. So you can see it's moving a very little bit, and getting further away from and closer to my mouse like that. Now, the difference that we're seeing here, when we talk in position, we talk in units of 1. But when we talk in angle, we still talk in units of 1, but 360 of those units, or degrees, make a complete rotation. So, as we had -1 to 1, that's only a range of 2 degrees, which is why we've got such a small movement. So if I put that to 0 and 360, we'll start to get that complete spin. Let me just bring that down a little bit in size. There we go. And I'm actually going to put that wave onto a saw, because I know that will give me what appears to be a continuous, never-ending spin. I'm just going to take the speed down on that a little bit as well, because it's feeling a little bit fast for my eyes. And if you look at the top of that, you can actually see the perspective kicking in. So as it gets closer, the components get bigger. If you look next to my mouse, you see that the corners seem closer to the points of the mouse than the faces themselves. And then again, if we just go back to the output page, we can actually see that within the projector beam. Now, if you've got a completely accurately modelled 3D model of your surface, like we had for the rotating Lego example, then you will be able to auto-map this on. Auto-map being the 4-point selection and placement tool that's available at the top here in AI. So let's go in for the last one now. So the last one that I've saved is, of course, the biggest and best, as you would hope. So let's think about how we would do morphing stage components. So if you remember, a few years ago we worked on a very, very well publicised Bon Jovi show, and for that we had 52 moving hexagonal columns, each of which were independently morphable from a very short column to a very tall column. So what we're going to do here, I'm actually going to bring in the Morph Module, which is a module itself. Now, usually when we use the modules in the stage patch, we don't see a screen fixture icon at the bottom. So what we're going to do is we're going to use this standard screen fixture and play all of our content on the standard screen fixture, and we can use the layers and all that kind of stuff. Then we'll take the texture itself, place it onto our 3D model, and then we'll also push this one out of the way so that it doesn't fall in the beam of the projector. So first of all, let me just go into my stage construction page and then just move that screen over to the side, like so. Okay, so next what we want to do, we want to go into our stage patch, and we want to add the modules in. So let's just move those over a little bit with the left keys. So I'm going to right click, I'm going to insert module, and I'm going to choose import and 3D morph model. Now, to use this module, you can load multiple 3D models into the module at the same time, and provided those models have the same amount of vertex points, you can morph between them in real time. So I'm going to press load. Now, I've set myself up a couple of models already. I've got B1 and B2, so one of them is a short version, and the other one is an elongated version, and it will give the impression of a growing surface. So I'm going to select both of them at the same time, and I'm going to press open. And you can do this with more than 2 models, but it is just purely a linear progression between those models. But it does mean that you can do very complex choreographed stage movements. So if we now go on to, and I happen to know that I need to just adjust the rotation on this, let's just do that first. I'll just put me around in the right orientation. There we go. So let's have a quick go to our stage construction page. Now we can see already, we can see this surface within AI. We note that it hasn't got any texture, but if I go to the output page, we'll see that the projector as yet cannot see this, and this is because, as I said, it doesn't technically have a screen fixture. So what we're going to do is we're actually going to tell the projector where to look. Now, to do this, we're going to do a couple of things. Now, before I do this, I'm just going to connect up a texture port on the Morph module to the canvas out on our screen fixture, so that will relay our texture onto this 3D surface that we've got here. So let's just confirm that again, so you can see there now it's textured. And then what we are going to do, we're also, just for now, let's just add a morph control in there. Now, I'm going to group these into what's called a sub-patch. So a patch is a thing which contains modules. So if I select both of those, I press Ctrl-G for group, and it's going to put them all inside one little box for me. And I'm going to just click up there, and I'm going to call it tower. Now, traditionally, on older versions of AI, we connected screens to the screen fixture. On this version of AI will see all screen fixtures because it has the usual fixtures button ticked by default. There is also a way that by text we can tell it where to look. So, what I'm going to do, before I do that in fact, I'm going to give myself another window module, and I'm going to connect it directly to the output of the output page that it's using for the projector. There we go. Cool. So hopefully in a moment, when we get this working properly, we'll see something pop into this bottom window here. In fact, if I get rid of that top one, we'll just leave that one there. We should see that pop in. Okay, so if I go back to my stage construction page, my stage patch page, sorry, on the projector fixture, I'm going to right click, and I'm going to choose load alternate skin, and I'm going to choose sub patches. That's the bottom on that pop-up menu. So what we can do here in sub patches, we can tell it to look at patches with specific names. So I called my patch tower. So if I simply write tower, because it's by default this module looks in this stage patch, so as it's just in the stage patch I don't need to put a complete address, then when I press enter, hopefully we should see it pop up here on the left, like so. Now before we go any further, I'm going to pull my projector out. In fact, no, I'm going to push my 3D model back. That will make more sense. There we go. Okay, so we're almost there. So remember I said I had a large model and a small model. Obviously this is our small model. Now the constant that I have connected to this morph control will allow me to, in real time, adjust the morphing between those modules. So as I move it, the tower grows. Nice and simple. Nice and simple. Okay, so obviously I've got just a manual control there. Again, this could be our motion control kinesis. It could be Ethernet data, so you could be using Ethernet, TCP IP or Ethernet data coming in. This could be an ArtNet data if maybe you're controlling it from a console or something like that. Really, however you want to do it. The real wonders about doing this sub-patch thing as well is it means you can actually start to use multiple modules in there. We can give ourselves an offset on the position there, so you can see I've now got two towers, each of which are separately controlled. Let's maybe throw a third one in there just for good measure. And let's put him over to there. There we go. And then let's just really throw a couple of oscillators in there again. And so this, the range just needs to be 0 to 1. The morphing value range is always a range of 0 to 1. Like so. I'm going to just offset those speeds a little bit so we get something nice going on. Connect those up to the morph control. Like so. Like so. And then let's just for good measure go to our output page and see what our projector's seeing. So, as I mentioned, I'm using the on-screen controls. This could be external control of any data type at all. As long as you can get it into AI, you can use it as a tracking signal. So what I've shown you here, this is exactly the same principle as we used for the 52 column setup for Bon Jovi. Obviously, the Bon Jovi patch is a little bit more complex. It's essentially 52 of these modules, each with an independent morph control going into them. If you're sensible as well, you could actually map, if you modelled each of these towers as separate 3D models rather than using the same model, you could actually UV map it so they show independent sections of the content at the same time.